Good day everyone. Today I will discuss our work in Group 3 in solving quadratic inequalities. Unlike quadratic equations where we only find the values of x, quadratic inequalities require us to determine the range of values that make the inequality true. We can solve them by factoring, graphing, and identifying the correct solution set. For number 1, it is x squared plus 4x minus 12 is greater than 0. We ask ourselves, what two numbers multiply to negative 12 and add to positive 4? The answer is 6 and negative 2. So the expression becomes 6 minus x mi sorry, x minus 6 and x plus 2 is greater than 0. So we set each factor equal to 0. X minus 6 is equal to 0. So x is equal to 6. X plus 2 is equal to 0, so x is equal to negative 2. These values divide the number line into 3 intervals. We tested values from each interval. When x is less than negative 2, the product is positive. When negative 2 is less than x and less than 6, the product is negative. When x is greater than 6, the product is positive. Since our inequality is greater than 0, we chose the positive intervals. So the final answer is x is less than negative 2 or x is greater than 6. Here, we show our graph and our solution which determine the inequality as true. Let's now move on to number 2. For number 2, it is 4x squared minus 25 is less than or equal to 0. Notice that this is a difference of squares. So 2x plus 5 and 2x minus 5 is less than or greater than 0. So we set each factor equal to 0. 2x plus 5 is equal to 0. X is equal to negative 5 over 2. Next, 2x minus 5 is equal to 0. X is equal to 5 over 2. These are our boundary points. For the left interval, it is positive. For the middle interval, it is negative. For the right interval, it is positive. Because the inequality is less than or equal to 0, we include the middle interval and the endpoints. So the final answer is negative 5 over 2 is less than or equal to x is less than or equal to 5 over 2. Here is our graph and our solution that make it false and true. Let us now move on to number 3. Y is greater than 4x squared minus 64. Our third example is a quadratic inequality in two variables, so we solve it by graphing. When x is equal to negative 2, y is equal to 4 multiplied by 4 minus 64 is equal to negative 48. When x is equal to negative 1, y is equal to 4 multiplied by 1 is equal to 64 is equal y is equal to 4 multiplied by 1 minus 64 is equal to negative 60. When x is equal to 0, y is equal to negative 64. When x is equal to 1, y is equal to 4 multiplied by 1 minus 64 is equal to negative 60. When x is equal to 2, y is equal to 4 multiplied by 4 minus 64 is equal to negative 48. The graph forms an upward opening parabola. Because the inequality is greater than, we used a dashed parabola. Since y is greater than the parabola, we shaded the entire region above the curve. Here, it shows our graph and our solutions. Let's now move on to our last number. For number 4, y is less than or equal to 4x squared minus 16. When x is equal to negative 2, y is equal to 0. When x is equal to negative 1, y is equal to negative 12. When x is equal to 0, y is equal to negative 16. When x is equal to 1, y is equal to negative 12. When x is equal to 2, y is equal to 0. So, since the inequality is less than or equal to, we drew a solid parabola. Because y is less than or equal to the parabola, we shaded the region below the curve. So here it shows our graph and our solutions. In conclusion, in this lesson we learned that solving quadratic inequalities is different from solving quadratic equations because we need to identify the values that make the inequality true. By graphing the quadratic function, we were able to locate the vertex, axis of symmetry, x-intercepts, and determine whether the parabola opens upward or downward. This helped us understand the behavior of the graph. We also learned how to interpret the graph to find the solution set. We discovered that inequalities with greater than or less than use a dashed boundary, while greater than or equal to or less than or equal to use a solid boundary because the boundary is included in the solution.